Fortinet has redefined network security with its Fortigate next-generation firewall across the entire attack surface that organizations are facing today. Fortigate firewalls are rated as the best security appliances worldwide. In this course, you will learn how to consolidate advanced security and network capabilities to protect against threats and attacks, how to manage your FortiGate to provide comprehensive threat protection for your office, how flexible it is to deploy your FortiGate in the edge of the organization or maybe in network segments, how to gain visibility to your organization. So what will you learn? You will learn how to set up your firewall, understand its operating system, administrate it using the graphical user interface and its command line, create groups and user groups, create interfaces and zones. You will learn how to deploy your FortiGate in a NAT operation mode and transparent operation mode and understand the differences between them. You will understand your routing table, how to create static routes, and how to create a firewall policy. You will learn how to set up SSL VPN portal and IPsec tunnels. This course is for everyone who wants to administrate its FortiGate fast and simple and make its way fast to deliver secure traffic with the best security appliance out there. Most FortiGate devices comes from the factory with a default setting. That is, port 1 is already configured with the IP address of 192.168.199 with a DHCP service already running. So make sure in your computer that you have in your network setting DHCP enabled. Plug in your Ethernet cable to port 1 of your FortiGate and the other side to your Ethernet connector. Let's check out our network settings just to see if DHCP is enabled, or maybe we are using a static IP address. So let's check the properties of our network adapter. And it is already configured to obtain an IP address automatically using DHCP. We can also set up our computer to 192.168.1 and use another IP address from the pool. Let's use 111. The subnet mask is a 24 subnet mask. The default gateway is the 192.168.199, and we can use just about any DNS server out there. All right. Now that was on a Windows 7 machine. It's an old operating system running on my virtual environment, but you can do it on just about any platform. I can, on my Mac, go to network preferences. Now it depends on our adapter, since many Macs nowadays doesn't come with an Ethernet port on the device itself. So you probably will use an adapter where you can configure manually or use DHCP. Just be sure to be on the same subnet as the 192.168.1.0 subnet. And so the next thing to do is to type the address of port 1 into your URL bar in your browser. You can also see a fav icon of Fortigate. And there it is. The default settings, which you should change, is admin with no password, but as a security expert, you should change your admin username and your admin password as soon as possible. Alright, so let's start our journey. You don't have to have a physical device. You can use a Fortinet support site and download a virtual image of Fortigate device into your virtual environment. Once you get into the support site, create an account, download a virtual image. You can choose your platform of choice. I'm currently using a VMware, and there are different versions that you can use. I'm using 6.0.4 and download it in your own time. Now, the next thing to do is to head over into your virtual environment, import your image, and continue the setup. Once it is done, you will be asked to log in into your Fortigate, use the admin username with no password, and there you are. You're at the Fortigate command line, where we will see, using show system interface, the different interfaces that are available. I remind you, we will now set up a management interface. We will now set up an interface that we will use as an admin to get into our Fortigate and configure the different settings, configure policies, set up new interfaces. To do so, let's choose port 7 as our management interface. We will use the following command: config sys interface, edit port 7, set IP. Now, this IP will be used as our management interface. Set IP, we will choose the 10.0.3.16 as our IP. The subnet mask will be 255.255.255.0. The next thing is to set up the management protocols that will be used to get into that interface. Well, we can use HTTPS, we can use HTTP, we can also use SSH, but in our case, we will only use HTTP. And that's it. Now, the next thing to do is to get on to our browser, use the IP address that we have used as our management interface, 10.0.3.16, and we will be prompted to enter our user credentials. We will stay with the default credentials, which are admin with no password. Alright, so let's enter our Fortigate interface using the interface IP address that we have just configured. The default username is admin with no password. We will change it later on. So we have our Fortigate dashboard. That's our main dashboard. We have different widgets with different information. We will look at each. The very first thing that I usually do, which is an administrative task, is to head over to the system menu, administrators. We can see that I'm assigned as the admin. I am allowed to enter the Fortigate from just about any subnet or any IP address out there. We can configure our trusted host, the places that the admin can enter the Fortigate. We will look at that. My profile is super admin. Super admin is the same as root in a Linux machine. The type of profile or the type of user is local. That is, my credentials are stored in the Fortigate hard disk, in the Fortigate memory. We can also assign a profile or a user from an outsourced remote server such as a Radius or LDAP. I'm not using a two-factor authentication. Now let's look at the different admin profiles. There are main two profiles. The first one is the super admin, which actually has permissions to just about anything. It has the read and write permissions to any place in the Fortigate interface. The second profile is the professional admin. So professional admin is usually a limited admin. It has different read and write permissions which we as super admin can determine. So let's create a new professional admin profile. Let's log out and enter again as the new professional admin and see the differences. So we will create a new administrator. It will be a local administrator. That is, the credentials are stored in the Fortigate. We are not using a remote server. We'll assign a very simple password just for the demo purposes, and the administrator profile will be proof admin. All right. So now let's move over to the admin, which is in the top right side of the interface, and log out. And let's log in again as the new professional admin. We'll use the author_SHM username and the password, the new password that we have just created. All right, it looks similar, but when we will move over the different menus, we will see that as a professional admin, which has only the read permissions, we cannot do anything. We can only see the current configuration. We cannot create new interfaces. We cannot edit current interfaces. We cannot create new policies. We cannot edit a policy. We can only view the current status. So we have two admin profiles. We have the super admin and we have the professional admin. For security reasons, we have to assign trusted hosts. Currently, both admins can enter from just about any IP address or any subnet. But let's change it. So we will restrict the login for the professional admin to the 10.10.10.10 IP address. And let's see what happens when we log out and log in. Let's log out. Let's try to enter with the same credentials. And we currently, our host is assigned with the 10.0.3.16 IP address, which is different than the trusted host that we have configured. And if we will try to log in, we will have an authentication failure. So let's log in with the professional admin, the super admin profile. Let's change it back to just about any place. All right. Sorry for that. 10.0.0.0. I have an extra 0 here. All right, so now both admins can enter from just about anywhere. We can also change the trusted host using the CLI. So if we will click the CLI console, which is a JavaScript console, we can use the config sysadmin. Now, currently we have two admin profiles, so we'll edit the author_SHM profile, which is the professional admin profile. We can move between the different admin using the tab key, and we can set trusted host 1 to just about any IP address or any subnet that we require. All right. And now let's refresh our page. And we can see that we have a new trusted host. We continue with our first setup. We have just created two admins for our FortiGate. One was the super admin and another professional admin. So let's move over to System, Settings. Here we can change our host name, our FortiGate name. You don't have to do it, but sometimes it is a good practice. If your FortiGate is located at a specific segment in your network, protecting a data center, protecting the finance division, well, you can name it accordingly. So let's change it to DC1. Sorry for that. Data Center 1. You can also change the system time. You can configure a specific NTP server. You can change the different ports that are used to enter the FortiGate, port 80 for HTTP port, or maybe it can be port 81 or port 8080. We can also change the SSH port, the telnet port, and the idle timeout. Currently, it is 5 minutes, but it can be up to 480 minutes. The other settings are related directly to the way that FortiGate inspects traffic and configure different policies. Those are the inspection mode and the next generation firewall mode. We will look at both later on as we discuss security profiles. One of the main responsibilities of a FortiGate admin is to back up the configuration. For many reasons. If something happens, you have a safe backup. If you have to troubleshoot something, help team will probably ask you for your configuration. You can back up your configuration in two ways: plain text and encrypted configuration backup file. You head over to the admin at the top right corner of the dashboard. There you have the configuration backup. You can back up your configuration on the local PC that you work on, or on a USB disk if it is inserted on your FortiGate. You can encrypt your backup configuration using a key, or you can save it in plain text. Let's see the differences. Let's back up our configuration. We will wait for the file to download. Let's open it up. That's our file. And there it is, all in plain text. We can see in the header, the model is Fortigate 90D. The firmware version is 6.0.2. That's the build. And as we can see, all is in plain text, but passwords and passphrases are being hashed using SHA-hash function. So every place we have a password or a passphrase, it is being hashed. Now let's back up our configuration using a key. Okay, let's wait and open it while it downloads. All right, and that's our encrypted backup. Everything here is being encrypted. It looks as it is gibberish. Now, if we need to restore our backup, all we need to do is go again to the admin menu, configuration, restore, and choose our backup configuration file. If it is encrypted, we need to enter our key. Now, one thing to note and remember it. If you wish to deliver or transfer your FortiGate configuration to another FortiGate, which is a typical scenario in many deployments, you have to have the same model. If your configuration is encrypted, you will have to have the same model plus the same firmware and the password itself. Alright, so we have created an interface using our command line. The interface, the management interface, is on 10.0.3.16. Let's enter using our admin credentials with no password, of course you should later on change it. You should define your own username with a strong password. Now I'm using a real FortiGate device, so my interface ports are a bit different from the ones that I have created or configured before. But let's choose one interface and let's use it for management interface purposes. So currently I'm using port 8. An alias is a good way to describe the interface purpose, so I'll call it admin. Now there are different roles for FortiGate interfaces. They can be used as LAN interfaces, they can be used as WAN interfaces, or DMZ interfaces, or undefined. For our purpose, we will use undefined. Now we can change the IP address. Let's decide that the IP address that we will use will be 10.10.11.1. We are using manual addressing mode, that is static IP that we configure and that is not configured by the DHCP. We can also use PPPoE or an interface that is dedicated to FortiSwitch, which is out of the scope of this course. We will use 24 subnet mask, and that will be the interface IP address that will be used to enter our FortiGate on different occasions. Now let's move over to administrative access, which are actually the protocols that are used to enter that IP address. Well, we should not rely on unencrypted protocols, so we should use HTTPS, and whenever one gets into the interface using HTTP port 80, it will be redirected towards port 443, which is the HTTPS secure protocol. If it is an internal, if you want to get into your FortiGate device and check connectivity internally, you can use ping. If you're using it remotely, don't use ping. Ping is, or ICMP echo messages are a risk. FMG access is FortiManager access. It is not needed for administrative purposes. CapWAP is also not needed. It is a protocol that is being used to create a tunnel between your FortiGate and your FortiAP, your Forti access point. FortiGate can act as a controller for wireless access points. Now we will not use the DHCP server or the DNS server for our purposes. The administrative interface is meant solely for our purposes as admins. It is not used to allocate IP addresses. We will not use services such as DNS to resolve IP addresses. We do not need to use captive portal. It is not meant to be used on a management interface. We can use the FTM, which is the FortiToken Mobile, which is a way to access our interface using a two-factor authentication, which is a topic by itself that we will look at it later on. One of the most powerful tools of your FortiGate is its command line. Now, you can do many things using the graphical user interface, but you can do just about anything using its command line. We won't go into each and every command. There are thousands of commands, but we will go into the basic syntax. We will understand it, and a good FortiGate engineer must know its command line by heart. The basic syntax goes like that. A command which can be config, show, get, execute, a subcommand such as edit, and an object such as interface. And you will use values and fields and different options when you use the command line. Now let's move over to some examples. The get command retrieves information about the operation or the performance of your Fortigate unit. So if we use get hardware CPU, we will get an output that details information about all of the CPUs in our Fortigate unit. Another command is the config. We use it to change our Fortigate configurations. You will probably use config more than anything in your Fortigate, at least at the beginning when you start to configure your Fortigate. Now, a good example of the config command is config system interface. That allows you to configure the different interfaces in your Fortigate. Now the next thing after config system interface, the subcommand edit. There you will edit different ports, and that only is available from within the scope of the command. Another very useful command is the show command. The get and the show command use mostly the same syntax as the config command. They display different parts of the configuration, but unlike the get command, the show command does not display settings that are assumed to remain in their default state. One of the few exceptions is the show full configuration command, which displays the full configuration, including the default settings. So we have our 40 almost set up, and the next logical thing is to create users and users group. So let's head on to the user definition and create new user. Now your user can be either local, that is, its credentials are saved on the Fortigate storage or Fortigate hard disk or flash drive, or it can come from a remote server such as a Radius, an LDAP server, or a Taka server. We'll create our user currently as a local user. So the next thing is to write down its username, use a password. Let's assign an email to our user. We will not use two-factor authentication. And that's about it. Now our user is created, but it doesn't belong to any user group. So let's add up a user group. Let's call our user group test users. We'll assign the new user to our user group, and that's about it. Now we have a user group with one member, which is the test user. Now this user group or user group, this user or user group will be used later on in our IPv4 policies to allow or to deny access to different places or different destinations internally or on the internet. Now we can also create new users and assign them to different user groups in our command line, and that's so. Now let's add another user, but this time using the CLI. So we'll use the config user local, that is a local user, and we'll name it edit test user 2. The first one was test user 1. Now a new entry is added, and we need to assign this user a password. So we'll set type password, and set password 1 2 3 4 5 6, and let's see if our new user was created. There he is. That's our new user that we have just created using the CLI. So the next thing to do is to add up our new user, test user 2, to the group that we have created in our last lesson, which is test users. Currently, test users has only one member, which is test user. So we will do it using this CLI. Let's config user group. Let's edit the group that we wish to add the new member. And let's set the members of that group, test user and test user 2. And let's end and refresh our page and see what happens. All right, so currently we have 2 members in our test user group. There are tons of ways where we can grab information on our system status. We are only at the beginning, but still we can see some valuable information. Some of it will not mean anything to us currently, but later on as we progress, the information will become much more clear. We can use the GUI interface to grab information using the log and report, traffic that is passing through the different interfaces, traffic that is being handled by the Fortigate itself. But we can also use the CLI, the command line, to grab some valuable information. So the first command is the get system status, where we can see our version, which is currently 6.0.2, the build number. We can see if our virus or IPS database are up to date. We can also see our host name. We can see if we are using a hard disk to log any event on our Fortigate. There are devices that come with a hard disk. There are devices that store their logs to a special device called a FortiAnalyzer. And there are those devices that use their flash memory for log recording. We can also see if we are working on an HA mode. An HA mode is a high availability mode where we use another Fortigate as a redundant Fortigate in case that one of our Fortigate stops working. We can work on both modes, whether it is a passive mode or an active mode. We will look at the high availability modes later on. We can also look at the system time. Now let's see the interfaces that we have on our Fortigate. So we'll use the show system interface. And there we have it. We have the different interfaces. Some of them are already configured, such as the WAN 1, which has that IP address, that subnet mask. We can see the management protocols that are being used, such as ping, HTTPS, SSH. We can see that that interface is a physical interface. It is part of the Fortigate switchboard. There are also virtual interfaces, such as VLANs. Another command is the get sys session list, and that will show us sessions that are being held right now on our Fortigate. We can see the protocol that is being used. We can see the source of the session itself. We can see the destination. And if we were using NAT, we would also see the NAT that is being used. One of the most used commands is the diag_systop, where we list the different processes that are running on your Fortigate. So we will use the diag-sys-stop, that is the command, and let's run it, and I'll stop it from showing all the processes. Now, that is the process name. That is the process ID. If we wish to kill the process, we can use the process ID later on. That is the process status. S is for sleep, R is for running, and there are more statuses. That is the utilization of the CPU. And that is the utilization of the memory. So whenever you need to troubleshoot an issue that is being caused by high memory utilization or high CPU utilization, check out the different processes that are running on your machine. We continue with the system status report. The next command is the get system performance status. Now, this command will output the CPU in terms of usage, the uptime of your system, the average network usage, the amount of sessions that are occurring in average every minute, how many viruses are caught. Currently, I have no virus that is caught. How many attacks, how many IPS attacks were blocked, and so on. Next up is the show system DNS. If we wish to get our DNS, our primary DNS IP address and our secondary DNS IP address, we can also take a look at our DHCP server as it is, configured on different interfaces with the star IP and IP, current default gateway. We can also get a view of the full configuration of our Forti using the show full configuration. We can also use the show full configuration with the grep command. Grep command is a Linux command that allows us to pipe a specific command into a specific output. So let's see how we do it. We'll use the show full config, and now we'll use the pipe and the grep command. We'll use -f to list the full configuration setup, and let's see specifics on the internal 5 port. And there we have it. Our specific interface internal 5 belongs to the root VDOM. It has the IP address of 10.0.2.1, and its management protocols that are supported are only ping and SNMP. Now, using grep makes everything much more faster. Let's do another example. Let's use the show full config, and let's grep a specific user, which we already know that he is one of the admins of our system. This user is OfferSHM, and let's see. Let me stop it. All right, so we know that he is a professional admin. We have configured a trusted host that he is allowed to enter our Fortigate from the 10.10.10.0 subnet, 24 subnet. We know that he belongs to the root VDOM. We also know that he doesn't use a two-factor authentication, and he didn't set, or we didn't set, an email that is related to him. Now let's look at the administrators. There he is. And yep, we can see that he is a professional admin. We didn't set any email, we didn't set SMS or two-factor authentication, and his trusted host is only the 10.10.10.0 subnet. Some other CLI commands that will help you to get a closer view of your system. Get firewall policy will show up the policies that are around. If you use the show firewall policy, you will see their full configuration. Another useful command is related directly to logs. Get log disk settings. Now this will show you the current configuration for your log recordings. One thing to note, Fortigate reserves 75% of its hard disk, internal hard disk. If you have a Fortigate, it supports a hard disk for logs. The other 25% are reserved for different things. You will get your first warning whenever your reserved space exceeds a threshold of 75%. You will get your second warning when it exceeds 90%, and the third one when you exceed 95%. These are all settings that can be changed. The maximum log file size is 20 megabytes, and whenever the disk is full, you can choose either to override it or keep it with no logs. So let's see how we can change the configuration. Config log disk settings, show full, and there it is. Set disk full, override, or keep it with no logs. One of the more confusing concepts of Fortigate or Fortigate interface is the feature visibility. Not all features or capabilities are shown on the Fortigate interface. Fortinet allows us to configure or to set up the features that we need for our tasks. There are tons of features available. So let's move over to System, Feature Visibility. As you can see, there are different features that are enabled, such as antivirus in the security features or switch controller in basic features. And there are features that are not enabled, such as intrusion prevention or application control. So if we would like to configure a security profile for one of our policies, we will see that not all security profiles are shown. Currently we have antivirus, web filter, DNS filter, but IPS is not shown. So we can enable it, apply, and there we have it. We have intrusion prevention available, and so we can use that sensor, that IPS engine, in our policy. Now on each feature we can click on the plus sign to see what is the feature. Let's enable another feature. Let's enable application control, one of the most used security profile in our policies. And let's move over to security profile. Let's apply it. Let's move over, and there it is. We can use application control to allow different application, to block different application. It is all categorized in different categories. We can also monitor different applications if we are not sure if they harm our network or not. Another very useful command beside the config command is the execute command, and in this lesson we will look at the execute ping, a very useful tool for troubleshooting connectivity issues. So we can use the execute ping just as we use it in other platform, and send ICMP echo messages to different websites to see if we have connectivity to that website or to a specific server in our local area network. But ping is much more powerful than that. We can use different ping options to set up different parameters. So let's take a view. Alright, so if we type in the execute ping options, we can type in the question mark and see the different options. Let's use another or a different repeat count So we will send not 3 packets, we will send 10 packets towards google.com. Another very useful feature of the execute ping option is using the source option. The source options allows me to set up the source that will send a ping packet towards any destination. So let's see how we do it. We use the ping options and my source will be, let's see, what is the IP config? Let's see what's the IP address of my Windows machine. It's 10.0.3.95, so I can use it as the source. And I will send a ping from that source towards google.com to see if that computer has connectivity. And yes, it does. Now don't hesitate to play around with those ping options. You will find them very useful for troubleshooting. As admins, we want to receive an email alert on everything that happens in our network. Any configuration change, any threat, any anomaly detection. So we need to configure an email server, an email account, and the different logs that we wish to get notifications on. We will look at logs and reports later on, but now let's see how we configure Gmail as our SMTP server. So the things to do is we head over to the System menu, Advanced, Email Server, use Custom Email Server. Now, since I'm using a Gmail account, I will use the domain of Gmail, which is smtp.gmail.com. The port that Gmail uses in its secure Gmail is 587. D for reply, let's use one of my emails, which is Orange Hello. Authentication, I'll use the Orange Hello address and the password. Alright, so the next thing to do is to choose the security mode. Security mode that is used by Gmail is Start TLS. We can, I believe, also use SMTPS, but Start TLS works just fine. And let's apply. Alright, settings are saved successfully. The second thing to do is to head over to Login Report, Email Alert Settings. Now let's enable email alert settings from my email to the same email. And now let's choose which email alerts I'm interested in. Any intrusion detection, any disk usage that exceeds 75%, any administrating login and logout, any configuration change that is being done on my Fortigate will be alerted using the email settings. And alright, any virus that is detected will also be sent over to my email. Alright, so let's apply. And now let's check it out using logout and login to the same admin profile. And let's see if I'm getting an email alert to my Gmail account. Moving over to my Gmail account, I can see that I have an alert, an email alert coming from my Fortigate to my Orange Hello Gmail account. And if I'll move over to the login report system event, which are events happening at this system level, we can see that the admin has edited its alert email setting. One of the key topics that you will master using your Fortigate firewall is policies. So what is a policy? Why do we need policies, and how do we configure policies? Well, a policy is a rule that when a traffic flows from one interface to the other, it matches different patterns of the traffic. It matches the interface that the traffic comes from, the destination interface that the traffic is heading towards. It also matches the source of the traffic, its IP address, if it belongs to a user or a user group. If it belongs to a specific device, it can be a PC, it can be a smartphone. And when done, when traffic matches your rules, your specific patterns, then the policy takes the security profiles action, which is an intensive process that looks into the payload itself and looks for different patterns to identify the traffic, to look for viruses, to look for anomalies. We will look at IPS and antivirus later on. And then when all goes well, the policy decides whether to NAT the traffic and whether to log it. Policy is actually a three-step procedure. Let's look at a very simple policy. We will create one now. Now on our policy, the first part is the part where we look for matching traffic. Let's name our policy. Let's call it full access. And let's decide that we wish to allow any user that sits on a specific LAN. It can be your marketing division LAN, it can be your finance LAN. Each LAN will probably have a different subnet to get out to the internet over the outgoing interface, which is our WAN interface. Our WAN interface is the interface that is connected to our ISP. Now, in terms of source, we will allow any source to get out to the internet. We can also limit it to specific users or different user group. We can create a user or a user group using the plus sign. We can also limit the traffic to a specific device. So if we, for example, want only Linux devices to get out to the internet, we can limit it to a Linux PC. Now, we will not do it. As for destination, we are not limiting. We will let anyone get out to any destination, but we can limit the destination towards a specific address. As for scheduling, we can limit our policy to work on a specific day, on a specific hour, but we will not do it. Anyone can get out to the internet always. And the last part of the first step in our policy procedure is the service. We can limit the service to be HTTP, HTTPS, or any other service, any other protocol that we wish to limit our users, but we will not do it. Users can use just about any protocol, any service. And then we decide on the action. Are we accepting the traffic? Are we denying it? Or maybe we are using it as a learn policy. A learn policy is a very specific policy that actually triggers security profiles beneath that no one really knows that it's there, and it learns our traffic and creates a report that we can look into and see users, traffic, most used applications, threats, and so on. The second part is the UTM profiles. We can initiate any UTM profile, any security profile on our policy. And the third part is whether we are enabling NAT. We have seen how NAT works using a NAT overload, IP pools, or maybe central NAT. And then we decide whether we want our policy to be logged with log all sessions or only security events. That's the basics of a simple full access policy. Your FortiGate can operate in two operating modes. The first one is the NAT mode, the network address translation mode, and the second one is the transparent mode. What are the differences? Well, if you remember your routing and switching lessons, it would become simple. In a NAT mode, your FortiGate acts as an OSI layer 3 device. It is actually a router. Each interface has its own IP address and its own broadcast domain. In a transparent mode, your FortiGate acts as a switch. Interfaces doesn't have any IP addresses, and frames are being forwarded according to the MAC address of their destination. Your FortiGate splits the network into multiple collision domains. Now let's see how we can change our FortiGate from a NAT operating mode to a transparent operating mode. We'll use the command line config system settings, and if we will use the show full command, we will see that currently our operation mode is NAT. If we wish to change it, we'll use the set op mode, and we can switch between NAT and transparent mode. We will use a new virtual machine that we will configure in transparent mode to learn more of its transparent mode capabilities. When do we use transparent mode and when do we use NAT mode? Well, most of the times you will use the NAT mode. Your FortiGate will act as an OSI layer 3 device where each interface has its own IP address and each packet is being sent according to the routing table. Now let's look at the routing table. We'll use the get router info routing table all. And we can see that we have one static route which will route any packet that doesn't have a route in the routing table to the WAN1 interface. We also have two other connected networks that are connected directly to our FortiGate. So that happens on a NAT mode. But what happens on a transparent mode? On a transparent mode, your FortiGate delivers the frames according to the MAC address table. When we use a transparent mode, we use it to scan the traffic between different segments of our network without any interference to the current routing that is already happening on the network. That is one of the reasons that we use transparent mode. There are cases where we split our network into different segments, and between each segment we deploy a FortiGate. FortiGate will still scan the traffic, will still use security profiles, will still use its next generation firewall capabilities such as IPS and application control to block or to allow the traffic, but it will not interfere with the organization routing that is already being used there. Alright, so we have moved from NAT mode, network address translation mode, to a transparent mode. And when we have spoke of a FortiGate that works in a NAT mode, we have said that packets are being destined according to their IP address header, and their destination is being checked against the FortiGate routing table. In transparent mode, it's different. We're not doing routing, we're doing switching. So let's check our MAC address table. Alright, we'll use the diagnose netlink brctel name host root.b, and that's our MAC table. So if you will look closely, you will see that most internal ports have the same MAC address. They did not associate with any new MAC addresses. The reason for that is that this device is rather new and I haven't attached any other devices to the internal ports beside internal one. Internal one has my D-Link camera attached to it. We can check out using its MAC address against a Wireshark UI lookup tool to see that this MAC address belongs to D-Link. A FortiGate in a transparent mode holds many interesting concepts such as virtual wire pairing and forward domains. We will look at them on our next video. In a transparent mode, every interface is on the same broadcast domain, even if we have interfaces that have associated VLANs with their own broadcast domain. So every packet that arrives, FortiGate will broadcast it towards any internal interface until it finds the destination MAC address. But this could be an issue, especially on large networks. So the thing to do is to create different domains for different interfaces, or to split the broadcast domain into several broadcast domains. That is called a forward domains. So what we will do, we will create 3 internal VLANs to internal 6, 7, and 8 interfaces. We will create the same forward domain for those 3. So any packet, any frame that arrives on one of those interfaces will only be broadcasted towards the other 2. Let's start. Let's create a new interface. Let's call it 100 and the VLAN ID 100. All right, so let's use the alias marketing. Okay. And now let's create a new interface. Let's associate it with internal. I believe that I haven't associated 110 finance. I believe that I haven't associated the earlier VLAN to internal 6. Let's take a look at it. Yep, I didn't. I associated to internal 1. That's okay. Let's create another VLAN. Let's name the interface 120, the VLAN 120, internal 6. Let's call it IT. And so currently we have a VLAN associated with internal 6, a VLAN associated with internal 7, that's VLAN 110, and a VLAN that is associated with internal 1. And now let's group those three internal interfaces into one domain. So let's do it using our command line, config system interface, edit. Let's start with internal 1, set forward domain, and let's name our domain ID 11. All right, and let's do next. Let's edit internal 6. All right, set forward domain 11. Let's do the final, which is internal 7. Internal 7, set forward domain 11. Next, and all right, so we have actually created another broadcast domain. Any traffic that comes in on internal 1 or internal 6 or internal 7 will only broadcast to those interfaces. So you have connected your FortiGate into the network. You have assigned an IP address that will be used as your management interface. And your first task is to connect the marketing division LAN to one of its interfaces. So how do we do it? Each interface, each port on the FortiGate physical switchboard can have an IP address. We can also use hardware switches or soft switches where we aggregate several ports into one IP address, one interface, where all traffic will broadcast to the different ports. But for our purpose, for our demo, we will use internal 5 as our interface and assign an IP address to it. Let's do it. We will call it marketing LAN in the alias field. It is a physical interface. We are not using a virtual interface. We will use a virtual interface later on. As for its role, it's a LAN interface. Alright, so the addressing mode, we will not get our IP address from a DHCP. We will assign it a IP address. Now let's assign another IP address. Let's assign 10.0.2.1 with a 24 subnet. So we will have 254 IP addresses available, if we choose so, to our marketing hosts. The next thing to do is to configure which administrative access do we want to use. We can use ping to check out if there is connectivity as admins, but we will not allow anyone to get into the interface using HTTP or HTTPS. We can also use SSL. And now we will enable the DHCP server. The DHCP server, which we will have a dedicated video for the different services, will allow us to allocate IP addresses to the different members of our marketing LAN. It starts from the 10.0.2.2 up to the 10.0.2.254. The NAT mask is 24, subnet of 24. The default gateway is the same default gateway as the interface IP, which is the 10.0.2.1. So any host in the LAN that will connect to that interface will get a gateway of the 10.0.2.1. Any traffic that is coming from the LAN will be forwarded to that gateway. We can use the same system DNS as in our FortiGate, or we can use a specific DNS such as the Google DNS. Now we can also assign different options to our DHCP server. We can define the list time, we can define more things. We will do it later on. Device detection is always good. Device detection allows FortiGate to understand which device is connected to the interface. That is a crucial parameter if we want to use later on a device-based policy. If we want to allow, for example, only Android devices to get out to the internet, or block Mac devices. We can also use active scanning, which is a method that FortiGate uses in the case that it doesn't recognize the device at first. We can use admission control as a captive portal. We will not use it this time. We will use it later on. So we have our interface. That interface is dedicated to the marketing LAN. And the next thing to do is to grab a switch, connect every host on the marketing LAN to that switch, and connect that switch to our interface, to our new marketing LAN interface. The next thing to do is to connect our marketing LAN to our WAN interface, the interface that goes to the internet, to our ISP modem. And then we will configure a static route. So our next topic is zones. A zone is a way to group different interfaces that don't have any references, such as firewall policies, and group them together into a logical zone that will be used later on in our policy configuration. It will make things much simpler. So currently we have only internal 5 that is dedicated to our marketing LAN. Let's add up another port and dedicate it to the finance LAN, which is another segment of our network. Alright, and let's define it as a LAN. Let's give it the IP address of 10.0.4.1 on the 24 subnet. Let's allow ping and SNMP. A DHCP server, we know that we currently have only 15 employees, so we'll allocate 20 IP addresses for that segment. Default gateway stays the same, DNS server stays the same. We can enable device detection with active scanning. Now, once we do it, we have 2 different interfaces. One is dedicated to the marketing LAN, the second one is dedicated to the finance LAN. Now we can create a new zone. We will name it Unified LAN. We can also name it DMZ or whatever. And we'll set up the members of that zone, which are marketing and finance LAN. And once we do it, we will see that we have a new logical interface in our interfaces pane. That is the Unified LAN, which includes internal 5 and internal 6, marketing and finance. We can use that zone in our policy configuration to configure one unified policy that all members of the marketing and finance LAN will have to obey. So you have configured your first LAN interface, and now it's time to enable its DHCP service. A DHCP server running on your interface, letting any client that connects to that interface get an IP from its pool. Now let's see how it is done and what else can be configured on your DHCP server. Let's move on to one of our interfaces. You know what? Let's edit a new port, a port which we haven't touched up until now. Let's quickly configure it as the internal LAN, and let's assign him a role as a LAN, and now let's assign a new IP address for that interface. Let's enable administrative access through HTTPS and HTTP. Let's add up ping also, and now let's enable DHCP server. Now we don't have to use the whole pool. We can use specific number of IP addresses that will be assigned to anyone who connects to that interface. Let's assume that we would only want 40 IP addresses. So the pool will start from 10.10.9.2 up to 10.10.9.42. Now the subnet stays the same. It's the same 24 subnet as we configured. The default gateway also stays the same. The default gateway for anyone who connects to our LAN interface is actually the IP address of our interface. The DNS server can be the same as our system DNS, and it can also be another DNS server if we choose to. And then we move on to the more advanced options of our DHCP server. The fact that we can configure a DHCP server on our interface doesn't mean that we have to. There are times that we already have in our organization a DHCP server already configured on a Windows server or a Linux server. Now we can use the relay mode to forward any DHCP request that comes from clients that are connected to our interface to the specific DHCP server that is already serving our organization. But in our case, we will use the internal DHCP server that is in our work. We move on to two more additional capabilities of our DHCP server. The first one is the additional DHCP options, and the second one is the MAC reservation plus access control. We will look at the DHCP options at our next video, where we will also configure the DHCP option. But let's start with the MAC reservation plus access control. The MAC reservation plus access control allows us to bind a specific IP to a specific MAC address, or maybe to block a specific MAC address from getting an IP address. So let's create a new MAC address. All right, and now we can see that we have three options. The first one is reserve IP, the second one is assign IP, and the third one is block IP. First option, reserve IP, allows us to reserve a specific IP address. Let's choose the 10.10.9.23 to that specific MAC address. Now the second option, assign IP, will make sure that the same device with that MAC address will get an IP from the DHCP server and will get the same IP address time and time again, assuming that its list time has not expired. Now the third option is quite self-explanatory. The device with that MAC address will not get an IP address from that pool. So let's continue with our MAC reservation and access control. If we already have clients that are connected to our interface, we can choose add from DHCP client list to add them to the list of MAC addresses. For unknown MAC addresses, we can decide either to assign IP or to block them from getting any IP address from our DHCP server. Now, let's see how our DHCP server configuration looks through the CLI. So you will use config sys DHCP server. Our DHCP server number is 6. Let's use the show full to see the full configuration. And we can see that the pool starts from the 10.10.9.2, ends at the 10.10.9.42. We have 40 IP addresses available. Our default gateway is 10.10.9.1. Our subnet is a 24 subnet. Our interface is internal tree, and our list time is the default list time. And if we will keep on clicking, we can see that our DNS server is the 8.8.8.8. Let's change it to 1.1.1.1. And let's refresh our page to see if the changes were saved. Yep, our changes were saved. We can configure our DHCP server either in the GUI or in the CLI, whichever suits you best. We move on to DHCP options, or sometimes called DHCP scope options, and let's understand the role in our DHCP server. All right, we'll move on to the advanced features of our DHCP server, and there's our additional DHCP options. Well, DHCP options are actually settings that are applied to our clients whenever they get an IP address from our DHCP server. They also get different settings. DHCP options have different codes, different numbers. Some of them are vendor specific, some of them are more generic. Let's create a new DHCP option, and this option will be DHCP option 252, and it will redirect our clients that are connected to our interface to a specific proxy that we have configured. So using the DHCP option with the string and not the specific IP address or hexadecimal value, we can write down the address of our proxy server using port 8080, and that proxy server, whenever the clients will connect to it, they will download the proxy.pack. A pack is the proxy configuration file. Now, once we save our new DHCP option, we can go into the command line, use the config DHCP, config system DHCP server, edit our server, which is server number 6, show full configuration, and let's see if our new DHCP option is there. That's right. Config options, edit 1, set code 252, set type string, set value into our new proxy server. Well, not every DHCP option is as simple as the one that we have just configured. Throughout your work, you will probably configure different DHCP options that will require you to translate IP addresses into hexadecimal values. Sometimes you will have to add a hex prefix before. Use DHCP options, learn whatever is needed. It is a powerful tool when configuring your DHCP server. One of the key concepts of switching and routing is the usage of a virtual local area network, a VLAN. Imagine that you have a local area network that consists of a switch and different stations that are connected to its port. This kind of a network is considered to be a one broadcast domain. Every frame that is being sent in the network is being broadcasted all over to every member that is connected to the switch. In your home network, one broadcast domain may not be an issue, but on large networks where you have dozens and hundreds of devices, there are members of different divisions, that is marketing division, finance division. You have to use virtual LANs. You have to split your network into different broadcast domains. It makes your network much more secure and much more efficient because fewer devices receive unnecessary packets. You can configure your VLANs either on transparent mode Fortigate or on a NAT mode Fortigate. Once you do it, your ports are becoming a trunk port. That is, a port that is capable of delivering packets from different domains, and not only the domain that was configured initially on the physical interface. So let's move over and create some VLANs, and in that way we will understand the usage much more clearly. Let's head over to our network interfaces, and currently we have two interfaces. The one is connected to the marketing division, the second one is connected to the finance division. Now, that interface is also connected to a switch in our marketing division where everyone is connected using their desktop computers. Now we want to divide traffic that is coming from the marketing employees and the marketing managers. We can create another interface or configure another interface to be used only for the marketing managers, but we want to do it on one physical port and divide that port into two broadcast domains. The one is the broadcast domain of the physical port, which is the 10.0.4.1, and another one will be created using a VLAN. So let's name our interface name as 110. Let's use the ID tag of our VLAN also 110, and let's use the marketing managers as our alias. Now we'll use the 10.0.5.1 IP address on the 24 subnet mask. Alright, so I already used it, so let's do this 6.1. Alright, now we will also use a DHCP server, and let's enable administration access using HTTPS and HTTP. Alright, once we do it, we can see that on the internal one interface we have actually created another broadcast domain which belongs to the marketing manager. That VLAN has the ID tag of 110. And now on our switch we can configure VLAN. It doesn't matter if it's a Cisco switch or an HP switch. We can configure a VLAN on the ports that are connected to the marketing manager's desktop computers. Once we configure a VLAN on that port, a VLAN that belongs to the 10.0.6 subnet, which is our broadcast domain. Any traffic that will come from our marketing managers through that switch will head over only to the new VLAN that we have created. And now we actually have two broadcast domain, two secure networks that are divided, but they are logically exist on one internal interface. Now, our interface, once we configured a new VLAN, has become a trunk interface. It will deliver all the traffic that comes through that internal one interface, all the native traffic, and that's why we say that the native traffic is the native VLAN, but also the traffic that comes from the second broadcast domain that we have just configured, which belongs to the VLAN 110. So once we have created a VLAN for our marketing managers, we can create different policies. One policy for the marketing employee and another for our marketing managers. So let's head over to our policy and object and create new policy. And now let's name this policy marketing employees. Marketing employees comes from the marketing interface, from the native VLAN. The outgoing interface is the WAN interface. The source is all, destination all, but we will allow our marketing employees only to use the FTP service. And we will log all sessions. We can enable different security profiles. Our second policy will be targeting our marketing managers, but this time with no limitation. We will use as the incoming interface our new VLAN, VLAN 110. The outgoing interface is WAN1. Source is all, destination is all, and service all. Hey everyone, so you have your Fortigate and its switchboard includes physical ports. Each can be configured with its own IP address or be associated to a virtual switch, either a soft switch or a hardware switch. That is, we are actually creating switches within the physical switchboard. But what is the difference between a soft switch and a hardware switch? Well, the difference is that in soft switch, the implementation itself is done at the software level and not on the hardware level. That is similar to saying, okay, port 1, port 2, port 3, you all belong to a soft switch that we will name it marketing, and it will have an IP address of 10.0.0 and so on. In a virtual hardware switch, the implementation is done over the physical ports themselves, where each port, each interface is configured in its hardware level to be a part of the same hardware switch. That is a much superior way to handle traffic, and in terms of performance, it makes a huge difference. Now, whenever a traffic enters the switch and it is destined to one of the interfaces that belong to that switch, decisions are made by the physical switch itself, its forwarding table, which is actually the MAC table. Alright, so let's configure a hardware virtual switch. Alright, so let's move over to our command line, config system virtual switch. And now, if I'll type the get command, I will see that currently I don't have any virtual switch already configured. So let's name one. Let's call our virtual switch, let's call it marketing, and let's set it up from the physical switchboard. All right, and now let's configure the different ports that will make out this switch. So let's use internal 4 and let's use internal 5 also, and let's use internal 6. All right, let's get back to our. All right, so now let's use the same command as before. Config system switch. Sorry, config system virtual switch, and let's see if we have a switch that is configured. Yes, we have. Here's our marketing switch. All right, now let's refresh our interface pane to see our new virtual switch, and there it is. Now if we will head over to our setting page of that switch, we can configure its IP address, its management. Let's use LAN 2 as our alias, and let's get him an IP address, and that's right, I'm using the same. Let's allow anyone to connect to it using HTTP and HTTPS, and let's allow ping also. And every device, every appliance that will connect to that subnet will get an IP from its DHCP server. And let's also add up device detection. Okay. And there we have it. We have a hardware virtual switch with its own subnet, with its own DHCP server. Any appliance that will connect to it will get an IP address from its pool, and any traffic that will head up to one of the interfaces that is within the marketing switch will be forwarded using the forwarding table. So you have set up your Fortigate, and it's now time to connect your local area network into one of its interfaces. On the other side, on the internet-facing interface, your WAN interface, you will connect it to your ISP. And assume that you have dozens or even hundreds of computers and only one public IP address. What can you do? Well, you use NAT, Network Address Translation. Your Fortigate acts as an agent that translates private IP addresses into your one public IP address. Without NAT, we would have need to purchase full class address range for our computers. Now, what does NAT do? Fortigate actually changes the IP address layer of every packet. So just imagine that by using a 24 subnet, you can use up to 254 IP addresses. That's amazing, using only one public IP address. Now, there are several types of NAT. We will look at them. There's the PAT, which is the port address translation. In Fortigate, we call it NAT overload. There is the central NAT. There's the virtual IP, But before we go over to the different types of NAT, we need to understand or to distinguish between two types of NAT. For an outgoing traffic, we use a source NAT. For incoming traffic, we use destination NAT. And NAT, as you will see, is part of your firewall policy. It is integrated with it, and you will use it in different scenarios. So we have learned of a source NAT for outgoing connection and a destination NAT for incoming connection. Now let's make things a bit more complex. We also need to understand what is a dynamic NAT and what is a static NAT. Well, a dynamic NAT maps the private IP addresses to the first available public address from a pool of possible addresses that you have got from your ISP. In Fortigate, this can be done using IP pools. The second type of a dynamic NAT is NAT overloading. This is the NAT that we use in our home. That kind of a NAT maps multiple private IP addresses to a single, only one public IP address. How does it differentiate between the different clients? It does so by using a different source port assignment. Now assume that the source port for a specific client is port number 1072. For another client, the source port is 173. Whenever a session is initiated, it is initiated with the source port. Whenever the web server, let's assume that we have asked for a web page, whenever a web server sends the responding traffic, it is based on those port numbers. So each session is actually mapped with the source port that the client initiated. Now let's take a look at our firewall policy and let's understand how we configure a NAT overloading and how we configure IP pools. Alright, so let's move over to one of our policies and see the different NAT that is being used. Now, as you can see, you can enable NAT or disable it. If you choose the use of outgoing interface address, that is many to one. Many private addresses will use only one public IP address. That is the NAT overload, but you can also use NAT overload in dynamic IP pools. Now, we don't have any IP pool that is configured, so we can add one right now. So if we use IP pools, we actually use a range of IP addresses instead of the egress interface as we saw before. We can name our pool. Let's name it IP pool. And as we can see, we have 4 types of IP pools. The first one is overload, that is many to one or many to a few IP addresses, and the port translation is used. The second one, one-to-one, well, the IP address, the private IP address is being mapped on a first come, first served, and we don't use the port address translation. Now the third one, the fixed port range allows better mapping between the internal private address and the external IP address. It also doesn't use port address translation. Now the third one, the port block allocation, it allows you to limit your client to a number of ports that can be used. You can use a specific number of port block size. Let's say that we use 65. Clients with limited port block size we're less likely to be influenced by a distributed denial of service where your network suffers from a flood of ICMP messages. So we have discussed dynamic net, and the opposite to dynamic net is static net. In static net, one internal IP address is always mapped to the same public IP address. A good example is when you have a web server on your private LAN and you wish that anyone that connects to your WAN interface, to your internet facing interface, will always reach that web server. Now, if you have a pool of IP addresses, you can assign one IP address to that web server. In Fortigate, we call it virtual IP addressing, or VIP. Let's see how that works. Let's move over to our network interfaces and create that virtual IP. So we have a WAN and an internet facing port, which is at 84.228.69.234. That's our public IP. And we have a local area network at the 10.0.3.0 subnet. Now, we have a web server that is located on our local area network, and that web server is on the 10.0.3.22, as you can see in our drawing. We need any host that is entering through our WAN interface to reach our web server on port 80. So the next thing to do is to create a firewall address with our web server address. Let's name it web server 1. Let's create the range for that. Web server. We can use our LAN interface as the interface, and that's about it. Web server 1 is our address object that we will use later on our policy. Alright, there we have it. And now the second thing to do is to create the virtual IP. Let's create the mapping itself. So we'll create a virtual IP. Let's name it to server 1. Interface is our WAN interface. The external IP range or IP address is our WAN IP address. The mapped, the IP address that we will redirect packets is the 10.0.3.22, and we will use port forwarding to limit our port mapping only to port 80. Alright. So we have created the firewall address, we have created the virtual IP. The third thing is to create our policy. Now let's name our policy to server 1. The incoming interface is WAN, the outgoing is LAN, the source is just about anyone, our destination is web server 1, our service is all. But don't forget to disable NAT, since we are already mapping it using virtual IP. And that's about it. Up until now, we have discussed a source NAT using the outgoing interface and IP pools. Now we can add more granularity to our NAT by using central NAT. To use central NAT, make sure that your FortiGate is in a policy-based, NGFW mode, policy-based. Now when you enable policy-based, you will see that in your policy and object you have a new menu, which is central NAT, where you can create a list of central NAT policies where you can determine not only the incoming interface and the outgoing interface, but also the source address, the destination address. You have full control of your IP addresses. You can determine if you want to use outgoing interface address but here you can also determine the port number or dynamic IP pools as we did before, but still decide which ports will be translated. You can create different central NAT rules. They will be read in a top-down methodology until Fortigate hits a matching rule for the incoming address. Whenever your Fortigate is deployed in NAT mode, in network address translation mode, it acts as an OSI layer 3 router. As a router, it does decisions on where to send different packets that arrives to it or different packets that it generates. Now, it does so using a routing table. A routing table is actually a series of rules. Think of each rule as the next hop. Now, the next hop doesn't have to be the final destination of the packet. It can also be a path to another router that will route the packet forward. Each routing hop in the routed path requires our Fortigate to do a routing table lookup that will pass the packet along until it reaches its destination. Now, Fortigate does two routing lookups for each session. For the first packet that is sent by the originator, and for the first packet that is sent by the responder. As it finishes its routing lookups, he writes the routing information in the session table, and all other packets that belong to that session will follow this path. Now, when your Fortigate tries to match a route to a packet destination, it may find some routes to the same destination. Which one should he choose? Well, it depends. It depends on the route attributes. The route attributes determine the best route. Alright, that's enough for now. We will look at static routes. These are routes that are entered manually. We will look at dynamic routing, which is configured dynamically using dynamic protocols such as OSPF. We will also look at policy routes, which is Fortigate's very advanced policy routing mechanism. We will look at the different routing attributes, internet services routing. So let's start. One of the most classic routes is the static route. You can do just about anything with a static route. The only disadvantage of a static route is that you have to manually configure it. That's the big advantage of dynamic protocols, dynamic routing protocols. Now, in your home setup, you already have a static route. You have a static route which is also known as the default route. That is, any packet that doesn't have a match in the routing table, send it over towards the ISP router. That is a static route that is being already configured using your router DHCP. Now let's configure one default route using a static route. So let's create new. When we create a default route, we actually say that any destination in any IP address on any subnet that doesn't have a match, forward it towards the following gateway using that interface. Now, as you can see, we also have a route attribute known as administrative distance, and we have another route attribute which is priority. We will look at them very soon. Now let's look at other scenarios where we can use static route. Now, let's assume that we have two WAN interfaces. One is connected to a very good ISP with low latency, high bandwidth, and the other one is connected to a medium ISP with a regular performance that the office uses. Now, you can use your static route to differentiate between different internet service. So if for Skype that you use from time to time, you will need the best ISP router that has the lowest latency. You can use static route to make sure that whenever you use Microsoft Skype or Netflix or any other service in Fortigate Internet Service Database, which is huge. Let's use Skype again. You can make sure that whenever you initiate a session towards Skype, the packets will flow or will be routed towards a specific gateway through a specific interface. Now, currently I'm using only WAN 1, but let's assume that I'm using LAN as my second WAN, so I can actually determine that whenever packets are destined to Microsoft Skype or whichever internet service, they will be routed using that static route. And now let's move over to the third scenario where we create a firewall address object that we will configure a static route that will destine all packet towards that address object. So let's move over to policy and objects, addresses, create new, and let's name our object remote LAN. That's a subnet that's in the 11.11.11.0/24. Now, to make it available in the static route configuration, you have to enable that button. Okay. Okay, now we move on back to static route, configure a new route, named address. Now once we have made it configurable in the static route, we can choose it. And now we can choose which gateway will be used. It can be that specific gateway in our LAN. No, this one is, let's use, that's our gateway. It can be that gateway or it can be another gateway, another interface that will lead to a specific router that will forward the packets. Next, we will look at routing attributes, as we said, and at the routing table. One of the route attributes that you will see whenever you deal with static routes or dynamic routing protocols such as RIP or OSPF is the administrative distance. Now, the administrative distance is a measure or a number that is used by routers to determine which route is the preferred route for the destination. The lower the number, the better the route. If your FortiGate has a connected network to it, then the route to it is numbered 0. That is, the best route is the route that is connected directly to your FortiGate. If it has a static route, as we have here, it has an administrative distance of 10. And so it goes on. OSPF is 110. RIP is 120. Now, if we have two routes to the same destination, the lower the administrative distance, that is the route that will be chosen. So if we have one static route that is to the default route that has an administrative distance of 10, and we will configure now another static route to the same destination, which is the default route. Now we'll choose another interface when to. Our gateway will be 10.2.99. Now we'll choose a bigger administrative distance. So now we have two static routes to the same destination, one with the administrative distance of 20 and one with the administrative distance of 10. Now if we will use the get router info routing table all, take a look. The only static route that leads our packets to the default route is the static route that was configured with the administrative distance of 10. That is the best match route that Fortigate finds whenever it sees packets who are destined to the default route. If we will use the database instead of all, we will see the whole routing table, which also includes the new route that we have just configured. But as you can see, the only one that is active is that static route. We have discussed distance as one route attribute that will be looked over whenever we have two static routes to the same destination. The lower the distance, the better the route. Now there is another route attribute, which is priority. We use priority whenever we have two static routes with the same distance. The lower the priority, the better the route, the better the path. Now on your routing table, you will see both routes, but the one with the lowest priority is the best path. So we have one static route towards our remote LAN that uses the LAN interface and another one that uses the WAN1 interface. Now let's see what is its priority. Currently it has a priority of 5. Okay. Another static route to the same destination which uses WAN1 and its priority is 0. Alright, so the WAN1 static route is the best or the preferred route. Now let's look at it using a routing table. Get router info routing table all. Now take a look. We have a static route. This static route leads to the 11.11.11.0 subnet. Now we have two static routes. We have one route, which is the preferred route, which uses WAN1 interface, and this second route, which is our second best route, and this one uses a priority of 5. Now, if we have two routes, it can be static routes, but it can also be dynamic routing protocols that share the same distance and the same priority. And in dynamic routing protocols, we also have another route attribute, which is metric. If we have two routes that share the same route attributes, Fortigate will load balance the traffic between the two routes. This is called equal cost multipath. Now we can control the load balancing parameters. We will look at that in our next lesson. When we have different routes to the same destination, and the routes all have the same route attribute, that is distance, priority, or maybe metric, then the Fortigate will load balance the traffic. Now this is called equal cost multipath, ECMP. but we can change the way or the parameters that Fortigate load balances the traffic. Let's see how we do it. Let's get over to our command line, config system settings, set v4 ECMP mode. Now, if you scroll, you will see 4 different methods. The first one, source IP based, all traffic that comes from the same source will be destined to the same route. Weighted IP based, that is, all traffic will be routed or will be distributed between different interfaces, and that is according to a weight number that we will configure on the different interface. We will look at it in a minute. Usage IP based, all traffic will be distributed towards a specific interface, and that is until a volume threshold is approached. We will also see how we configure a volume threshold to an interface. When it approaches, the threshold approaches, then the traffic will move to another route. And the last one is the source destination IP, and that is the same as source IP, but it also includes the destination. That is, all traffic that comes from the same source and destined to the same destination will follow the same route. Let's configure a weight to our interface. Let's use when1 set weight, and now higher weights are likely to be chosen. That is, the traffic will be distributed between the different interfaces or the different routes, but interfaces or routes that has higher weights will probably get more traffic. Now, we can set up the weight between 0 and 255, so let's set it up to 255, and that's it. So if we choose the weight IP method, when1 will probably get more traffic than other routes, other same routes that has lower weight. When we use the spillover method, that is when a threshold volume is approached on a specific route or an interface, the traffic will flow to the second route. Now, how do we set up a volume threshold? We use the same config system interface, edit the interface or the route that we want to configure the threshold, and then we use the set spillover threshold, and that is a value between 0 and 16 million. So let's just choose. Whenever we wish to connect through the public internet in a secure fashion, we use VPNs. We use virtual private networks that creates a tunnel that gives users or to remote local area network a secure access to each other's private network as if they were connected to the same LAN. A VPN uses different encryption algorithms, it uses different hash functions, and it uses different authentication schemes to make sure that only allowed users can access the private network, that no one can read your data, and that no one can touch your data. No one can tamper with the data that is being sent. There are 2 main VPN technologies that your Fortigate supports, and these are IPsec and SSL VPN. We will look at both technologies, understand the differences between them, when do we use each, and configure each separately. When we configure SSL VPN, we can deploy it in 2 modes, a web mode and a tunnel mode. A web mode requires only a web browser. It is much easier to set up. It is much easier to use, yet it supports only a limited number of protocols. A tunnel mode supports most protocols. It requires the installation of a VPN client that creates a virtual network adapter in your computer or in your smartphone. Now, the traffic tunnels using that virtual adapter. We will configure both modes, tunnel mode and web mode, in one setup. Let's start. Now, the first thing to do is to set up a user and a user group that are authorized to use our VPN tunnel. So let's create a new user. Let's name it Offer Shmueli. Give it the password. Let's skip email address and let's submit. Now let's create a user group. Let's name our user group SSL user group. All right, let's add our new member. And there we have it. That's our SSL user group, which will be allowed to access our tunnel. Now, one of the first things that I do whenever I set up an SSL VPN is check out the SSL VPN configurations. And let's do the show full. And we can see a bunch of settings. One that I'm interested in is the algorithm, set algorithm. So if we choose the high cipher suit, then we actually use symmetric encryption that is higher than 128 bit. If we use the medium cipher suit, then we use symmetric encryption that uses algorithms that are 128 bit and lower. And if we use the low cipher suit, then we can actually, or the Fortigate and the client that negotiates between them on the cipher suit can actually choose whichever cipher suit, and that could be in many cases lower than 128 bit, which is not recommended. So let's keep our cipher suit or our encryption algorithm high. All right, now let's move over to VPN, SSL VPN portals. Now, as you can see, we can choose the full access portal, which allows us to create an SSL VPN in a tunnel mode and in a web mode. We can also choose a VPN portal that allows us only to create a tunnel mode VPN or only a web mode VPN. We will use the full access VPN portal that allows users to get into the tunnel itself using their browser or using the Forti client, the dedicated VPN client. All right, so in tunnel mode, we have enable split tunneling. Enable split tunneling is whenever we want to split our traffic, one way is towards a specific address in our network, and that traffic will use our VPN tunnel. And the other traffic, which is usually destined to the unsecure internet, will not use any VPN. We will not use enable split tunneling. We will only use tunnel mode. So any traffic that goes up through our tunnel will get encrypted and will use the VPN tunnel. Now, whenever we use a tunnel mode, we are assigned specific IP addresses that we can configure, and that is the range, the IP address range that our virtual adapter assigns to whomever gets out through the SSL VPN tunnel. We can configure another address object that will be on another range and make sure that anyone that goes through our SSL VPN will be assigned an IP address from that range. But we will not do it. We will use the same SSL VPN tunnel address that is already assigned. Next, we have the client options, which allows it to save our passwords or to connect automatically. And now we head over to the web mode, and we will continue that on our next video. And there we have it, web mode. Now, in a VPN based on a web mode, users are actually connecting the Fortigate, which acts as a server, as a secure server. They do it using the SSL TLS protocol. Only users with credentials can enter the VPN itself, and they can do it over their web browser, which is an advantage, though it supports, as you will see, only a limited number of protocols. We will later on look at the SSL VPN settings and see that the default port that is being used is port 443, which is also used for HTTPS. But we will change it since the admin management protocol is also using the port 443. Now, whenever we enter our Fortigate SSL VPN portal, we don't get the IP address from the range that was allocated using tunnel mode, but our IP address, the client's IP address, will be the same as Fortigate internal IP address. Now we can change the message, the portal message of our VPN portal. We can call it, let's name it, work portal. We can use different themes, which allows us to customize the look and feel of our portal. Let's use the red theme. We can also use several different options as login history and session information. And the most important part of our portal is the predefined bookmarks. Those are the bookmarks that will connect us to different applications on our SSL portal. So if we'll use the create new bookmark, and let's name our bookmark Fortigate. And let's make that bookmark a bookmark that will connect anyone who uses that SSL VPN portal to the graphic user interface of our Fortigate, to the admin page of our Fortigate. So for that purpose, we use HTTP and HTTPS. But as you can see, when we click on it, we can use different protocols to access FTP sites or FTP servers. We can also use RDP, SSH, Telnet, VNC, and other protocols. The URL of our Fortigate is the 10.0.3.16, and let's name it Fortigate admin page. We will not use single sign-on, but only users that have credentials, and those are the users that we have already configured in the users and device, will be able to enter our SSL VPN portal. We can also customize different portals for different users or user groups. All right. And now we can also add, whenever we log in to our portal, the FortiClient download if anyone wishes to connect using tunnel mode and have all the other options have support for more protocols. Alright, so our portal is configured, and now let's head over to SSL VPN settings. So we will listen on interface, that is interface our WAN interface. We will not listen on port 443 since it conflicts with the administrative HTTP port, HTTPS port, so we'll use port 10443. And if you don't have a public IP associated with your FortiGate and you use another router before it, then you will have to use port forwarding to make sure that any connection that is targeted at port 10443 will be redirected to the 10.0.3.16 using that port that assigns it to the SSL VPN portal. And so it says that the web mode access will be listening at https://10.0.3.16, and that is the semicolon 10443 port. And that is the URL of our SSL VPN portal. And let's move on to other options. We can redirect HTTP to SSL VPN. We will not do it. We can limit access to specific hosts, but we don't want to limit access to specific hosts. We want any host to be able to enter our SSL VPN as long as it has the credentials. We can change the idle logout. Currently, as you can see, we are using the default built-in Fortinet factory certificate. My advice to you, use your own certificate. It doesn't cost much, and there are dozens of certificate authorities that will do it for you. Now, we will stay with the assigned address as we have configured before. That is the address range that our tunnel mode users will get as they log to the SSL VPN tunnel mode portal. And let's add our SSL group that we have configured before, and let's assign them to the full access portal. All right. And now the next thing to do is to create a policy that will allow users of our SSL VPN to enter our internal network and our Fortigate admin page. We will do it on the next video. So we have created an SSL VPN using tunnel mode and using web mode. Now the next thing to do is to create an address object of our local area network, so anyone that connects using tunnel mode will be able to connect to the entire local area network, and to configure a policy that will allow anyone to with the right credentials to enter our local area network. Any users that will connect through web mode will connect to the portal and directly to will have a predefined bookmark to the Fortigate admin. So let's move to policy and objects. Let's create an address of our local area network. We'll use subnet type, and we'll use the 10.0.3.0/24. And we will use it on our policy. So we have the address object of our local area network. There it is. And now let's create the policy itself. To SSL. And now our incoming interface is not our WAN interface, it is actually our new SSL VPN tunnel interface that was created using the virtual adapter. The outgoing interface is our LAN interface. The source is all, but it is also our SSL user group. The destination is our local area network. That's where we want our SSL VPN users to be able to get into. Now, service is all. If you wish, you can use any security profile, and that's about it. We also have the Fortigate warning that we use the built-in certificate. Use your own certificate. So once we have the policy, the address object of our local area network, our portal settings, our portal predefined bookmarks, we can head over to our new SSL VPN and see how it looks using web mode. So let's try to access our SSL VPN using the 10.443 there it is. We needed the HTTPS, and remember that the new user is also Shmueli and the password. Alright, and there we are at our new SSL VPN portal, and that's our bookmark. We can launch our bookmark and getting into the admin interface of our Fortigate. That was SSL in a web mode. Now let's use the tunnel mode, and for the tunnel mode we need the Fortigate client. The Fortigate client, the Fortigate's SSL and IPsec VPN client. So let's launch Fortigate client. Let's go to remote access, add a new connection. Our connection is SSL VPN. Let's name it work VPN, and the remote gateway is 84.228.69.234. Now I'm using a router that is before my Fortigate. So let's use customize port and save the connection. And let's connect. Now let's enter our username. We are moving to the second VPN technology, and that is IPsec. Now IPsec is different than SSL VPN. It uses different protocols. It is a bit more complicated to set up. You have to have your IPsec client in order to use it. It doesn't have any web mode, and it defines two phases to the creation of IPsec. The first phase is used between the remote peers to authenticate and establish a secure connection. The second phase is used to create the VPN tunnel. Now, as we will go on, you will see that you also have to create a static route. You will have to create the IPsec security policies. Alright, so let's start. Now let's move over to VPN. We can, since IPsec VPN is sometimes complicated, Fortigate made it very easy to create an IPsec tunnel. It actually has an IPsec tunnel template that you can use, or the IPsec wizards that allows you to create an IPsec easily between two sites or between a remote user and an IPsec gateway, such as the Fortigate. You can create IPsec between two Fortigates. You can create IPsec between a Fortigate and another IPsec supported appliance. And you can create an IPsec between a Fortigate's IPsec client and a Fortigate. But we will set up a custom IPsec, so we will go over through the different phases, and that will make everything much more clearer. Now let's look at the topology. Users from our local area network, which is the 192.168.1.0, will be able to connect directly to the remote local area network at the 10.0.1.0 as if they were part of that local area network. Between the two private networks, we have two FortiGate that will establish the IPsec tunnel. Our own FortiGate, which is the HQ FortiGate, has the public IP address of 84.228.69.234, and the remote FortiGate has the public IP address of 82.22.43 and 11. Alright, so we're progressing. Now let's create a firewall address object for the remote local area network that we want to establish a tunnel to. So let's create one. Let's name it remote IPsec LAN. That's a subnet at the 10.0.1.0/24, and let's use this static route configuration so we can use it later on in our static route configuration. Alright, now let's move over to VPN, IPsec tunnels, create new, custom, and let's name our tunnel since we are the initiator. Let's name our tunnel to branch. Next. Now we will look over at the different parameters, the ones that are really important, and I'll try to explain each. Now the remote gateway, that's our remote gateway IP address. We will reach to it through our WAN1 interface. Now we will not use NAT since we are not doing any network address translation. Both gateways have their public IP. They do not need to translate the IP address. It's a tunnel between both gateways. Now we can use dead peer detection that will check for any issues in our tunnel. Let's use a pre-shared key for the authentication between the two peers. Let's use the 1, 2, 3, 4, 5, 6, 7, 8. That will be the password that we will use. Now there are two modes at phase 1. The first one is aggressive, the second one is main. Using the main mode actually uses 6 packets to establish the first phase. The aggressive mode is much more quicker, it only uses 3 packets, but we will remain with the main ID protection mode. Now these are the encryption algorithms and the hash functions that are used. We can keep them as they are, we can eliminate some of them. Let's use AES 192 and SHA. Let's use SHA-1. Now the Diffie-Hellman group is the method or the way to initiate a secret key that both parties can use during the setup. we will keep the groups as 14 and 5. This is the key lifetime, 86400. We will not use local ID since we're only establishing one IPsec tunnel. And now let's move over to our phase 2. In phase 2, we will configure the remote and the local private networks. Now our local network and the remote address is the 10.0.1.0. All right, now we can move over to the advanced configuration where we can determine the encryption algorithms and the hash functions. We will keep it as they are. We will enable replay detection and perfect forward secrecy. That is a mechanism that initiates a new key each time this session ends. It's much more secure that way. And there it is. That's our tunnel. Step 1 is completed. Alright, so we have finished the first setup. We have created phase 1 and phase 2 in our IPsec tunnel. And we have also created a firewall address object of the remote local LAN. Now, let's create a static route that will tell our Fortigate how to reach the remote local area network. So we'll move over to network static route. And let's create a new static route. We'll use the named address since we have configured the remote IPsec LAN address object. And our interface is the to-branch IPsec tunnel interface. We're not using the WAN interface, we're using the new virtual interface that was created once we have set up our tunnel. Alright. So we also have a static route. And now let's configure the policy that will allow our local area network to reach the remote local area network. So we'll name it to remote IPsec. The incoming interface is our new virtual adapter, which is the to-branch tunnel interface. The outgoing is our WAN interface. Source can be all. We can also set up a user group or specific users, but for now we will use the all. Destination all, service all. We do not need NAT in our policy, and that's our first policy to remote IPsec. Now let's create this second policy. From remote IPsec. And this policy will be the opposite. That's the policy that will allow traffic coming from our WAN reaching our new VPN. Alright, so we have two policies in place to allow traffic between our remote local area network and our local area network using IPsec VPN. Now we have actually finished setting up our VPN tunnel from our side. The next thing to do is to set up the remote Fortigate. The remote Fortigate will be set up exactly the same, using the same pre-shared key, the same encryption algorithm, the same in different phases, the same hash values, The only difference is the IP addresses of the remote gateway and the remote local area network, which should be configured in the phase 1 and phase 2 configuration. Another thing to do is to set up the policies, the security policies, and the static route.